Wow. So, regression is the study of relationship between variables. There's all sorts of kinds of regression. Today we will talk about linear regression. Linear means line, first degree. Tomorrow we'll talk about exponential and logarithmic regression. It's really good stuff. When we see a relationship that exists among two variables, we say that they have correlation. So correlation is the strength of the relationship. You can say that certain things have no correlation. You can say that some things have high correlation. We'll give you an example. In a first world country, the literacy rate is 90%. The average number of TVs is 3.2 per household. In first world countries, the literacy rate is 32%. The average number of TVs is 1 per household. Therefore, if we want people to be able to read, we should give them more TVs. That's absurd, right? Well, okay. So my point is that the more TVs we see, generally the higher literacy rate as you look at countries across the world. But it has absolutely nothing to do with having the TV, does it? It has everything to do with educational opportunities, like Sesame Street. However, some people make this argument, and they jump to this piece. They say correlation is causation. So because there's a correlation between literacy and number of TVs, they say, well, number of TVs must cause literacy. That's absurd. Probably one of the most important things that you can learn when you are in high school is this one statement. Correlation is not causation. You won't be tested on this, but I'm just saying when you hear studies and they talk about correlation of pieces, 50% of studies are later proven to be false. Okay? So, like I said, correlation does not show causation. And so we need to be very careful in the world of statistics as we talk about those things. In order to describe certain trends, we look at a best fit line. Okay, this is your prediction equation. For our calculator today, it will have the form of y equals ax plus b. Your calculator uses a, not m. Have no idea why. The correlation coefficient is r. R always sits between -1 and +1. If R is negative, it means that there's an indirect relationship. If R is positive, it means that there is a direct relationship. For example, the more hours I work, the more money I make. That's a direct relationship. I work more hours, I get more money. Here's an indirect relationship. Any golfers out there? Okay, Maddie, if I increase my number of swings on the golf course, will that increase or decrease the number of wins that I have? It'll decrease the number of wins that I have, right? Okay, practice strokes. Okay, thank you, B. Rhodey. All right. Now, let's forget about that example. As the temperature increases, my cooling bill increases. As the temperature increases, my heating bill decreases. Yep. As the temperature decreases, my heating bill increases. So you can see some indirect and direct relationships there. Okay. So R does not tell us the slope, but it tells us something about the slope. For example, if R is 1, that does not mean that the slope is 1, but it does mean that the lines or that the points are nearly in a perfect line. Okay? You can see that they are positive They have a direct relationship, so the slope is positive, but the slope is not 1 necessarily, okay? If r is 0.5 means we have, that there's a relationship. It's not as well defined as the previous example. But again, they're trending upward. If you have r is equal to 0, that means that there is no relationship that can be described among the data. Elena, life will never get better until you take responsibility for your own actions. Blaming Travis for everything will not help. Okay. All right. Negative 0.5. You can see that there doesn't appear to be a very strong relationship, but you could try to draw some type of a line, and you can see that it's trending downward. Okay. R is equal to -1. Again, doesn't mean that the slope is -1, but it does mean that the slope is negative, and it's trending downward. The data points are very closely related. So let's try. If r is equal to 0.4, direct or indirect relationship? Direct relationship. Do you think that there's a strong relationship or weak relationship? Weak. Suppose r is -0.96. Direct or indirect? Indirect. Strong or weak? Very strong. Closer it is to 1 or -1, stronger it is. -0.02, that's really close to 0, so there's no relationship there. And if r is 0.89, it's a strong direct relationship. Strong direct relationship. What class do you have after this? Oh, you go home today. Wow. That's too bad. Take out your calculator. What's that? Letter C? There's no relationship. It's just about 0. There's really no relationship. Okay. Are you ready to focus on the calculator? Sure. Turn it on. Press Stat. In our Stat option, we will edit our lists. Press Enter on Edit. Raise your hand if you have something in your lists. Let us clear them out. Here's how you clear them. Go up to L2, press Clear, and Enter. I'll go up to L1, press Clear, and Enter. Some people may accidentally delete a list. Watch me as I delete a list. Oh no, where did it go? If I simply insert, and it looks like L1 sits right here, second L1, I can get it back with all of its data still there. So I will clear out my data. I have nothing there. All right, so I'm going to enter some data points here in order to predict some important pieces. Now it says make a scatter plot of the data, and we want to decide independent and dependent variables. I think that this is important for us to talk about. Independent is what we do think causes. So if there is one that causes another, we would like to say that that's the independent variable. Do you think that the temperature causes the heating bill, or do you think that the heating bill causes the temperature? So therefore, our independent will be the temperature, and then the heating bill will be our dependent variable. So in L1, I'm going to type the temperature, 38, 42, 44. Maddie's talking smack. No, you do not have to share your calculator. Okay, so those, as you notice my list, they are the same size. I have exactly 7 entries in each, don't I? That's good news for me. And now what I'm going to do is I'm going to actually view a scatter plot. So this is another part of your calculator you need to be used to going to. Instead of going into y equals, I go second y equals, and that will bring me to my plots. As you notice, I'd like to make a first plot. This is plot 1, and my plot is currently turned on. Many of you will have a plot that's turned off. If I press enter, it brings me into the screen. I can turn it on. I can choose what type of plot I want. Do you think I want 1, 2, 3, 4, 5, or 6? 1 is a scatter plot. I can verify that I want the x to come from L1 and the y to come from L2. If you ever needed to change that, you sure could. I also have these different marks. So this mark is what I like to choose. If you'd like a different one, it's a free country. Go right ahead. All right, I have my data. I now need to go into my window. What do you think is the smallest x value that I should use? Sure, 30 seems reasonable to me. Largest x value? 50. Smallest x value. Or I'm sorry, that's my scale. Smallest y value we'll call 65. Okay, or 60, whatever you want. And then my biggest y value. You okay? All right. What happened, dude? Okay. All right. I press graph, and that's what I come up with. So I have temp, and I have dollars. And I'm just going to make a rough sketch of what my plot looks like. It's not going to be exact, but, you know, does it look like there's a direct relationship or an indirect relationship? Yeah, it looks like there's a direct relationship. I'd also like to come up with a best fit line. Your calculator makes it very easy to come up with a best fit line. Here's what we do. Are you ready? This is where we're going to get lost. We have gotten lost every hour here. Stat. Calculate. Number 4, linear regression. At this point, if you have a fancy dancy calculator, your screen looks a little bit different than mine. So, Maddie has a fancy dancy one. Maddie, your screen asks you if you would like to store the equation, correct? I will show you how you store the equation. Go down to the store row, and everybody else, you can follow what I do. I want to store this as y1 so that it will actually graph it. So y sub 1 is a variable. So we select it from our variables. Vars, V-A-R-S, right next to the clear button. We select y variables. The line is a function. We are using function variables. And we select our y1. So by that one option, it will now store it in y1 so we can graph it. I press enter, and it calculates some important pieces here. Now, we'll write that down in a second, but before we do, is there anybody out there who does not come up with an R value? Okay, we're fortunate. Okay, so Justine, you do not have an R value. So here's what you need to do. Your diagnostics are not turned on. If you do not have an R value, please follow this. Press second and 0 for catalog. You're currently in the A's. You will hit D for diagnostics. Yep. By the C. I will start over. Second catalog. D for diagnostics. I'm going to scroll down to diagnostics on and press enter. And I have to press enter for diagnostics on. Done. It turned the diagnostics on. It's on. It's on for good now. So you manually turn it off. Okay, so calculate. Number 4, I'm going to store it in a y variable. And I press enter. There I have my a value, my b value, my r squared, and my r value. Now, here's what's really cool. If you go into y equals, you can see that the line is right there. If you go to your graph, the best fit line pops up right away. If you hit y equals, you can see that it stored the equation in y1. So there we have it. Okay. So let's flip over to the back side here. It says find the correlation coefficient. I'm going to write down r. I'm also going to write down r squared. And I'm going to write down the equation for the best fit line. And trust me, if you didn't follow everything the first time, we're going to do it 2 more times. Once on the notes and then once on your assignment. So as I quit this, I can see that r is negative 0.86. Are we surprised that the correlation coefficient is negative? No. The r squared value, we didn't talk about that, but it's 0.75. What that means is 75% of the variation in the data can be interpreted by the best fit line. So it means that the line represents about 75% of the data. That's kind of layman's term for what we're talking about. You'll never have to state that, but if you take a statistics course someday, they might talk about what r squared means. Okay, so then we want to write the equation. The equation is y equals negative 1.68 times x plus 148.88. I am a fan of not using x and y. I am a fan of saying that the dollars are equal to negative 1.68 times the temperature plus 148.88. Because then people know what to plug in where. So just like I used temperature and dollars in my grid earlier, I use it there. So now we can extrapolate and interpolate. It says, so if we plug in something for temperature, say my question is, what would the heating bill be if the temperature was negative 10? That would be extrapolating. If I would say, well, what would the temperature be if I had a heating bill of $100? That would be interpolating. Don't need to remember the words, but they do come up. Stop laughing at me, Terry. Yes, they are. They're real words. Talk to your English teachers. Okay, here we go. So my question here is, it says, predict the heating bill in a month where the average temperature is 40. So what do you think I do with that 40? So you got 3 options in order to figure this out. You can either plug it in and multiply, or you can use 2 different methods with your calculator. As you examine the graph, you could just go second, calculate, and I would like to calculate a value, number 1. And I type in 40, and it gives me the output. Trust me, what I wrote can't be shown. So, thank you. I appreciate that. So I got $81.73. Now, here's another way you can do it. A lot of you guys like to go to your table. If you go to the table, you can type in 40, and you're going to get 81.73 as well. So let's try to go through the next example a little bit more quickly and see if we can identify all the important pieces. Here's the number of teachers, number of students at randomly selected sample high schools in the city. Ignore the use teachers as an independent variable. What do you think is the predicting factor? Do you think the number of students predicts the teachers, or do you think the number of teachers predicts the students? Yeah, I mean, just because we hire a bunch of teachers here doesn't mean we're all of a sudden getting a higher enrollment, right? But if we do have a higher enrollment at Albert Lee, we're going to need more teachers. So I'm going to say that the independent variable is going to be students. And I'm going to say that the dependent variable is going to be teachers. And so as I make my chart here, students and teachers. All right, I got to go in and plug in some data. So I'm going to go stat. Let's enter. Sweet. Got all my data points in there. I'm going to consider my window. I'm going to make my window from 40 to 120. You okay with that? My Y values, I'm going to go from 300 to 1500. Oh, I switched that around, didn't I? Oh. So you're right, I did. I switched it around as I entered it. So if anybody else did that, I'll show you what you can do right now. It's really cool. So I wanted my L2 to be my Y value, right? So in your stat plot, just make your Y list L1 and L2. Or you could do this. Here's another thing you can do. I like to do this sometimes. I'm going to put my L1 over an L3. Boom. Now I'm going to put my L2 over an L1. Now I'm going to put my L3 over an L2. So now I just switched all my data. So my data points are good to go. I'll go back in my window. So it looks like I need my X values. I need from about 300 to 1500. And my Y values, we said from about 30 to 120. I'm going to get rid of this line in there because it's not going to work, but that's my data I get. Line. Equation best fit line. What do I press? Stat. Then calculate. Then 4. I want to store it. Variables. Y variables. Function. Y1. Same thing. You got to go down to store equation and hit your variables. Do the same thing. Now as I graph it, okay, what's the, yes. I'm going to write down my equation for my best fit line. First of all, R is equal to 0.68. So there is a relationship. It's not as strong as the previous one. We can see that our R squared value is equal to 0.46. So less than 50% of the variability in the data can be explained by the trend line. And then finally, you can see this value here. A is equal to 0.056, and B is equal to 35.19. So what that means is the number of teachers is equal to 0.056 times the number of students plus 35.19. So you can actually go into your y equals and type that in. For some, okay, so you four are all doing something different than what we're doing for some reason, and I'll try to help you figure it out. Okay, so it hasn't come up in any other class. I don't know what it is, so we might be switching something around. Your calculator might be grabbing a stored list by mistake. There's all sorts of things, and I promise I'll help you figure it out. So the question is, predict the number of teachers in high school, 600 students. I can simply go, well, first of all, if I go to my graph, that's there, and I could go second, calculate, and I want to find a value. So if I have 600 students, I've got about 68.87 teachers. So you can, so sometimes teachers, so I'm 1.0. So I teach a full load at 1.0. You have teachers who operate at 0.9. They teach one less class. You have teachers that operate at 0.8. So yeah, sure, you can. I would say that. So, you're not going to be tested on this, folks, but this is something that we should know. I've got a nice short worksheet for you. It just has 4 problems, okay?